Welcome to the today's tutorial. Today we are going to discuss about the integration by part. In this method we can solve the integration of the form integration fx g dash x dx or given as the product of two functions. For example, integration of x sin x dx or integration of x square e to the power x dx. Now we'll write the formula for integration by parts. Integration of fx g dash x dx, which is equal f of x multiply g of x minus integration f dash x g x dx, which is have also another form, and we can get that by taking u is equal fx and dv is equal g dash x dx. Then this gives du is equal f dash x dx and v is equal integration of g dash x dx, which is equal gx. So therefore the integration is reduced to
Now v du, it may be come in the form which you already know from previous knowledge from the table of antiderivative or by method of substitution. If it is not, again if it is coming in the product form, you will apply the by parts method second time to solve this integration v du. Now the important part is that how to choose u and v. So for example here I have x sin x dx. Now the question is what is u in this problem and what is dv. So I have the option here. Let's u is equal x, dv is equal sin x dx. So this is option 1. Second option is u is equal sin x, dv is equal x dx, and third option is u is equal x sin x and dv is equal dx. Fourth option, which is maybe not possible directly, so u is equal dx and dv is equal x sin x, so which is impossible. So therefore we have these three options to choose u and v. Now what is the correct one, or which one will gives us the perfect solution and quickly solution? So to follow this, or to get that substitution of u and dv, we generally follow this rule, liat, L-I-A-T-E. L for here, logarithm function. So you have ln or log ax. This function you will substitute first. So according to the appearance, you will choose the function as u, the remaining part as dv along with dx. So here I is the inverse function. Say tan inverse x sine inverse x, generally trigonometric inverse. A is algebraic. Let's have x square plus 2x plus 3 and x minus 2 whole square, like this. This one is trigonometric. So sin x, cosine x, tan x, like that. And this one is exponential. E to the power x, a to the power x, 2 to the power x, 5 to the power x, like this. So now how this assumptions will be? So let's have the last one, x sin x dx. Now here you will see this is the algebraic part and this is trigonometric part. So therefore by this rule you have to choose u which is coming first. So here a and t. So therefore a is equal x. So we'll take u is equal x and dv is equal sin x dx, and then if you solve it you will get the solution. Next we'll do the example according such arrangement of the expression. As we discussed in the previous slide about this substitution, and we are particularly doing the example algebraic expression and trigonometric function. So therefore we'll take the algebraic expression as u and the trigonometric as v. So in this case we have u is equal x and dv is equal sin x dx. So this implies du is equal dx. This implies v is equal integration of sin x dx, which is equal minus cosine x. We will avoid the constant c. We will put it in the end of the solution. Now by parts, implies integration of u dv, so which is equal uv minus integration of v du. So uv, u is x, v is minus cosine x, so this will be minus x cosine x minus minus a plus v du. So v is cosine x, du is dx. So this is equal minus x cosine x, and integration of cosine x is sin x plus 6. So therefore we have final answer integration of x sin x dx is equal minus x cosine x plus sin x. See. Our next example is x square cosine x. Again we will have the same algebraic expression and trigonometric function. So we'll take the same method as previous solution. So u is equal x square. This implies du is equal 2x dx, and dv is equal cosine x dx. So this implies v is equal, integration of cosine x is sin x. So our integration is reduced to u dv, which is equal uv minus v du. So this is equal uv x square sin x minus v du. So this is v sin x, du is 2x dx. So therefore we'll have here sin x multiply 2x dx. So this can be written as x square sin x minus 2 integration of x sin x dx. Now this x sin x dx apply by parts again. We already solved it in earlier example. Previous slide we solved it. So therefore I'm not going to solve it. So we just will write the answer x square sin x minus 2 x cosine x plus sin x plus c. So it will be x cosine x plus sin x, and then the final answer is c. So therefore the final answer is x square cosine x is equal x square sin x plus 2x cosine x minus 2 sin x plus c. Okay, next question we have integration of x secant square x dx. Again we have the same algebraic and trigonometric function. So we will substitute accordingly. U is equal x. So this implies du is equal dx and dv is equal secant square x dx. So this implies v is equal tan x. So therefore integration of x secant square x dx, which is equal u dv. So by parts we have uv minus integration of v du. So this is equal uv. So u is x, v is equal tan x minus integration of v. V is tan x and du is dx. So this is equal x tan x. So we'll recall the integration of tan x dx. This is equal minus ln cosecant x plus c or ln secant x plus c. So this will be minus ln secant x plus c. Our next example is also involved algebraic expression, trigonometric functions, but we have to be careful that here it is not the normal trigonometric functions directly. Here it is secant x square, it is not secant x. Therefore first we need to transform it with the trigonometric and variable, not any expression. So like secant theta or secant t, then we can solve it. So for that, first we have to substitute x square. So put x square is equal t. First step we will do that. Then it will gives us 2x dx is equal dt. So this implies x dx is equal dt over 2. So therefore our integration x secant x square dx will reduce to, so x dx will become dt over 2. So it will be secant t and dt over 2. So which is equal half of integration of secant t dt. So here again I need to recall the integration of secant t dt, which is equal ln secant t plus tan t plus c. So this is equal half ln secant t plus tan t plus c. But our original variable is not t, so we have to substitute back. So it will be half ln secant x square plus tan x square plus c. So in this case, this example gives us the idea that if there is a product of two functions, it does not mean that we should have applied the by parts. We can do other method also. So you have to be careful in such problem. Again another problem with the same idea or same concept. Here it is sine square root x. Now the thing is that where is the algebraic expression? So you will see that we can write it like this: 1 multiply sine square root x. So this 1 is the algebraic. So this is algebraic and this is trigonometry. So now how to solve it? Again, as in the last problem, this is not the normal trigonometric function, it's trigonometric and inside there is a expression, not the variable directly. So therefore we need to first reduce this part. So we substitute it here. Let t is equal square root x. So this will gives you dt is equal 1 over 2 square root x dx. So this will gives me dx equal 2 square root x dt, which is equal 2t dt. So therefore the integration sine square root x dx is equal, here we have t is equal to square root x, so it will become sine t and dx is become 2t dt. So this is equal to integration of t sine t dt. So this is, we have the question, the first question we solve it by parts. So we can apply that one and we have write the answer here directly. 2 minus t cosine t plus sine t plus c. Here we will substitute back the t. So 2 minus t is square root of x cosine square root of x plus sine square root of x plus c. Or next example is algebraic and exponential. So again I will recall. So algebraic first and then exponential. So therefore here we have to substitute u is equal x, dv is equal e to the power x dx. So this implies du is equal dx. This implies v is equal e to the power x. So therefore integration of x e to the power dx. So this is equal u dv, which is equal uv minus v du. So uv is x e to the power x minus integration of v du. V du is e to the power x dx. So this is equal x e to the power x, and integration of e to the power x is e to the power x plus c. Again, similar problem. We'll take u is equal x square and dv is equal minus e to the power x dx. So this will give you du is equal to x dx, and this will give you v is equal minus e to the power minus x. So therefore integration of x square e to the power minus x dx, this is equal u dv, so which is equal uv minus integration of v du. So uv is minus x square e to the power minus x minus v du. So v is minus e to the power minus x, du is 2x dx. So this is equal minus x square e to the power minus x minus a minus a plus 2 integration of x e to the power minus x dx. Now for this integration we'll do it separately. So let's have x e to the power minus x dx. Again here we will use the by parts separately. So u is equal x and dv is equal minus e to the power minus x dx. So du is equal dx and v is equal minus e to the power minus x. So x e to the power minus x dx, this will be minus x e to the power minus x and minus e to the power minus x, and here it is dx. This is equal minus x to the power minus x minus 7 is a plus integration of e to the power minus x dx, which is equal minus x to the power minus x minus e to the power minus x. So we substitute here. This is equal minus x square e to the power minus x plus 2 minus x e to the power minus x minus e to the power minus x plus c. This is equal minus x square e to the power minus x minus 2 x e to the power minus x minus 2 e to the power minus x plus c. Example is involving algebraic and logarithm function. So here we have ln x dx. So what is the algebra? Algebra is 1. So we can write this as 1 ln x. So again, if we say LIATE, so logarithm, and then we will have algebraic. So here we have u is equal ln x and dv is equal dx. So this implies du is equal 1 over x dx and v is equal to x. So therefore integration of ln x dx, so this is equal integration of u dv, so which is uv minus v d. So uv, what is u? U is ln x, is x, so it will be x ln x minus v du. So v is x and du is 1 over x dx. So this is equal x ln x minus dx. This is equal x ln x minus x plus c. You have to note that integration of ln x dx is not equal to 1 over x. Rather, derivative of ln x is equal 1 over x. This is some common mistake student used to do, that integration of ln x dx is equal to 1 over x. So be careful on this part. Now here again we have something complicated, but we see that this is not the normal product form. There is a power of this, so we need to reduce the power and we will check that what to do. So for that, first we will substitute ln x. Let ln x is equal t. So this implies 1 over x dx is equal dt. So therefore our integration ln x to the power 3 over x dx become a simple problem is 1 over dx is dt, so it will be t to the power 3. 3 is 1 over 4 t to the power 4 plus c, so it will be 1 over 4 t. What is t? T is ln x, so it will be ln x to the power 4 plus c. Next one is a cyclic form and you have to be careful to solve this problem. And here you will see LIATE, trigonometric and exponential. So but in this case, if you choose anyone u, anyone dv, there will be no issue. Why? Because both of this function has a derivative and the integration, and that will produce similar kind of the function. So that's why if you choose t trigonometric function as u or exponential function as u and dv vice versa accordingly, so you will not face any problem. So but we will try to keep the same rule as it is. So therefore we will choose u is equal sine 2x and dv is equal e to the power x dx. So this implies du is equal to cosine 2x dx and phi is equal e to the power x. So therefore here we will denote it for a purpose. I is equal e to the power x sine 2x dx. So sine 2x is u, and e to the power 2x, e to the power x dx is dv. So by parts we have uv minus v du. So uv, what is uv? U is sine 2x, v is e to the power x. So we have e to the power x sine 2x minus v du. So v is e to the power x, du is 2 cosine 2x. So 2 e to the power x cosine 2x dx. Now you'll see that we'll come back in similar kind of the problem. So therefore what we'll do, we'll solve this one is again. So e to the power x cosine 2x dx. We repeat the same process. So u is equal cosine 2x dv is equal e to the power x dx. This implies du is equal minus 2 sine 2x dx, and v is equal e to the power x. So therefore integration of e to the power x cosine 2x dx, this is equal uv. So e to the power x cosine 2x minus v du. So v du. So v is e to the power x, du is minus 2 sine 2x dx. So this is equal e to the power x cosine 2x minus a plus 2 e to the power x sine 2x dx. Therefore here we will reach it from this part, we will reach here e to the power x sine 2x minus 2, and then here you have e to the power x cosine 2x plus 2 integration of e to the power x sine 2x dx. But look on this integration, what is this? This is I. So therefore we can write this one as e to the power x sine 2x minus 2 e to the power x cosine 2x minus 4i. So now take this I on the other side, you will get it 5i is equal e to the power x sine 2x minus 2 e to the power x cosine 2x. This implies I is equal to 1 over 5 e to the power x sine 2x minus 2 e to the power x cosine 2x plus c. This is the integration. Now the example is the trigonometric function, inverse trigonometric function. So again here, so here we have the algebraic as well as the inverse. So we have this and this I and a. So we'll take I as u. U is equal tan inverse x, and dv is equal dx. This implies du is equal 1 over 1 plus x square dx, and
v is equal x. So therefore integration of tan inverse x dx, so this is equal u dv uv minus v du. So u is x, v is u is tan inverse x, v is x. So x tan inverse x minus v is x, du is x over 1 plus x square dx. Now to solve this integration of x dx over 1 plus x square, we'll substitute 1 plus x square is equal t, so we'll have 2x dx is equal dt. So our integration is reduced to half dt over t, which is equal half ln t. So therefore here you will get it here, x tan inverse x minus half ln 1 plus x square plus c, integration of sin inverse x dx. So same as the previous problem, we will write it here, u is equal sin inverse x and dv is equal dx. So this will give you du is equal 1 over square root 1 minus x square dx, and this is equal v is equal x. The integration sin inverse x dx is reduced to u dv is equal uv minus v du. So uv is x sin inverse x minus v is x over square root of 1 minus x square dx. Now again to solve this integration, we will put it 1 minus x square is equal t, so minus 2x dx is equal dt. So the integration will reduce to minus half x dx is dt, and it is square root t, so minus half t to the power minus half plus 1 minus half plus 1, so half cancel out, so this is minus square root of t. So this is x sin inverse x minus square root of 1 minus x square plus c. Next method is tabular method. It's a shortcut method of the by parts, and here we have the specific function. If derivative of u at certain stage becomes 0 and the integration function is continue, then we can use this method, and this method is will be done by as follows. So we make a table here. Here we will take this first function. So here f of x, g of x, f of x and derivative g of x and integration. So in this case, our f is x square and g of x is equal e to the power minus x. So the derivative is first is x square and here is e to the power minus x. Then derivative of x square will be 2x.
A derivative is integration of e to the power minus x is e to the power minus x. Then derivative of 2x will be 2, and here e to the power minus x. Then derivative is 0, and this will be e to the minus e to the power minus x. Then we need to connect it this to with the sign is plus, then this 2 with the sign minus, then this 2 with the plus. So therefore integration of x square to the power minus x dx is equal, here plus and this minus, so minus x square to the power minus x. Here you have plus and this minus, so minus 2x e to the power minus x. Here plus and minus minus 2 e to the power minus x plus. See, we solved this problem before with a little bit longer method. Here is the short method of such integration. Want to apply this by parts directly, you have to do 5 times integrations to solve this problem. But if you use the tabular method, it will become easy. So you have here x to the power 5, here is e to the power minus 2x. Then derivative of 5 is 5x to the power 4, and here it will be minus 1 over 2 e to the power minus 2x. Then here derivative is 20 x to the power 3. It is 1 over 4 e to the power minus 2x. Then here it is 60 x square. This is minus 1 over 8 e to the power minus 2x. Then here it will be 120x. This is 1 over 16 e to the power minus 2x. Then it is 120, and this is minus 132 e to the power minus 2x, and then this is 0, 1 over 64 e to the power minus 2x. Now it's a very long calculation. If you solve it, if you want to solve it by parts directly, so here you have, we will start from plus, then this is minus, this is plus, this is minus, this is plus, this is minus. So our answer will be 5 e to the power minus 2x dx. This is equal minus half x to the power 5 e to the power minus 2x. Then here minus this product, so it is both are plus, there is a minus, so minus 5 over 4 x to the power 4 e to the power minus 2x, and then here plus minus, so it will be minus 20 over 8 x to the power 3 e to the power minus 2x, then minus 60 over 16 x square e to the power minus 2x, and then here minus 120 over 32 x e to the power minus 2x, and then the last one is minus 120 over 64 e to the power minus 2x plus c.
So you have to just check that how the power is reducing of the x. 5 4 3 2 1 0 x to the power 4 sine 2x. It will also go simpler method. So in this case we'll have here x to the power 4 sine 2x, then derivative of x to the power 4 is 4x to the power 3. Integration will be half minus cosine 2x, then it will be 12 x square. This is minus 1 over 4 sine 2x. It will be 24x. This is minus and plus 1 over 8 cosine 2x. This is 24, and integration of cosine, it will be 1 over 16 sine 2x, and this is 0, and this is 1 over 32 minus 1 over 32 cosine 2x. So therefore the answer is dx. This is equal, so from here it will be minus half x to the power 4 cosine 2x, and from here 4 and 4 cancel out, so you will have here minus, so this is plus, this is minus, this minus minus a plus, 4 cancel out, so you will have here x to the power 3 sine 2x, and then you have here plus 12 over 8, you have x square cosine 2x, and this is minus 24 over 16 x sine 2x, and then here it will be plus, so it's minus 24 over 32 cosine 2x plus